Okay guys, here's our second example. If you look at your flow chart again, don't worry about E, you haven't learned about that yet. We cannot make the bases the same for this one because the only way to make 9 would be 9 to the first power or 3 squared. And the only way to make 7 is 7 to the first. So we can't make them be the same. So instead we're going to have to use common logs. So if you move all the way to the end, it says, does your equation have one exponential alone? This does not have one exponential. We have two. Okay, so when you go to no, it says, is there exactly one exponential on each side? This one does have exactly one on each side. So we're going to take the common log of both sides and then solve. So I'm going to log both sides here. The reason why I'm doing this is because then I can use my rules of logs or my properties of logs in order to solve this. So remember, when we have exponents inside logs, we can move them to the front and turn it into multiplication. So this becomes x minus 1 log of 9 is equal to x log of 7. Okay, I'm trying to make sure I have enough room to fit all this here. So think about solving equations. In order to solve an equation, we have to get the x's on the same side. And we have x's on both sides here. So in order to do that, I'm going to have to get this x out of the parentheses. Log 9, this is log base 10 of 9. It's the common log. If I type that into my calculator, it would give me a number. So I can treat this just like a number, and I can distribute it in. Like say this just said 9. Wouldn't I make that 9x minus 9? So I'm going to do the same thing here. I'm going to distribute log 9. So it's going to be x log 9. That's just log 9 times x minus 1 log 9, that's log 9 times negative 1, and then I still have x log 7 on the other side. Now that I've gotten the x out of the parentheses, I need to get my x's together to the same side. So I'm going to put these two to the same side, so I need to subtract this to move it to the other side. Okay, this side over here is negative log 9. There's no variables, so that's something I could type into my calculator and it would give me a number. And over here, I'm just going to write this. Remember, log 7 is a number, log 9 is a number. Since they both have an x on them, my job is to combine them. I want to combine like terms. So think about, if I were to have on this side, say it said 7x minus 9x. Wouldn't I make that negative 2x? I would combine them into negative 2x. So that's the idea here. We want to combine them together. But I don't know what log 7 is unless I type it in my calculator, and I'd have to round it. I don't know what log 9 is unless I type it into my calculator, and I'd also have to round it. So because of that, what I have to do here is I'm going to factor an x out. So this side is still negative log 9. And on the other side, I'm going to take the x out, which leaves me with log 7 minus log 9. So they both had an x, so just like when we do greatest common factor, I just take that x out. See, if I were to distribute it back in, I'd get what I started with. Now, if you look here, all of that, there's no variables. This is a number, that's a number. They can be subtracted. So I can get x by itself now. I can go ahead and divide. So I'm dividing by everything that's in this parentheses so that these cross out, which makes x by itself. And then I would have this. This is actually the exact answer for this problem, okay? I would need to take that and put it into my calculator to figure out the answer. So I would go ahead and do my negative log 9 and get an answer. I'm going to leave it in my calculator. And then I'm going to go ahead and divide that by my log 7 minus my log of 9. Making sure that you put parentheses around this stuff. So when you divide by the log 7 minus your log 9, you have to make sure you put parentheses around that so that you get the right answer. So in the end, x would be equal to, or about, I should put about, 8.743, about. That would be my answer.